very warm welcome. We're going to be talking today about the global engineering response to the Kakhovka Dam breach failure in Ukraine. It's a brilliant presentations from some great speakers. So it's going to be a really interesting event. I'm just going to go through some housekeeping. So the event is being hosted by Arcadis, the CIWEM Welsh Branch, and the CIWEM Rivers and Coastal Group. It is going to be recorded, so if you have an issue with that, could you put that in the chat, in the question and answers? We are only put recordings of our events up on the CIWEM website and the YouTube channel when the authors and speakers give us permission to do so, as long as there are no copyright issues. So that happens after the event. You can view the past digital series on the YouTube channel, and the link will be sent out. If you experience any technical issues or need any assistance, please use the chat feature on the Zoom window and let us know what the problem is, and we will try to help you. We will take questions at the end of the presentations. So if you'd like to put a question or make a comment about the talks, please use the Q&A facility as opposed to the chat, please. That is moderated, but obviously all relevant questions will be put through there. The chat is being held for the technical issues with Zoom only. When you're asking a question, please can you state who you are and who you're posing the question to, if you can, please. This event is offering 1.5 hours of CPD for the webinar. We do not provide CPD certificates, as this is not a CPD accredited training and only applies to CIWEM members. I am going to give a brief introduction to the event and the hosts of the event as well. I'm going to say that this is a technical event only. This is quite an important point. Clearly, there's a political dimension to this, and we're not going to touch upon the political dimension of it, and those questions on that will be moderated out. So CIWEM, I hope we've got some new people to CIWEM on this event. That would be lovely. CIWEM is a royal chartered professional body, an independent charity. It's the Chartered Institute of Water and Environmental Managers. CIWEM's vision is a world in which professionalism and excellence build connections to inspire widespread, impactful water and environmental solutions. I've been asked by the CIWEM team to point you towards on the website, and links will be sent out, CIWEM's Climate and Ecological Emergency Declaration, which is obviously critical, and the Planet Possible podcast. My name is David Mould. I work for Master in Environmental. I'm a hydrologist, and I'm tomorrow stepping into the chair of the Rivers and Coastal Group, who is one of the hosts. The Rivers and Coastal Group is part of CIWEM, and we aim to improve the understanding and sustainable management of rivers and coastal environments. And we do that via a variety of means, including promoting and sharing knowledge, developing our members, highlighting issues and commenting on policy, contributing to CIWEM policy. We provide expertise and input into the CIWEM flood and coastal erosion risk management specialist panel, and we build connections through collaboration and inclusivity. Can I say a thank you to all the hosts today? Jane and Barbara from CIWEM HQ have facilitated this, and they've done a great job and made it very easy. So thank you very much. And thank you to all the speakers as well. I think you're going to have a great event. It's really, really interesting. I'm going to pass you over to Catherine Hooley, who's going to introduce the last remaining host, which is the CIWEM Welsh Branch. Thanks very much.
Thanks, David. So I'm Catherine. I work for Arcadis in the UK as part of the flood risk and hydrology team, and I'm also a member of the Welsh Branch Committee. So the Welsh Branch is made up of about 450 members, and that can be anything from students to professionals to retired people. And the Welsh Branch itself is one of CIWEM's area branches. So we cover Wales up to Aberystwyth, and then North Wales is covered by North West and North Wales Branch. And Welsh Branch does actually extend just across the border into the Forest of Dean as well. So on the Welsh Branch Committee, there are about 13 of us, and we're currently chaired by Melissa Maravash-Snow from NRW, that's Natural Resources Wales. And this year we've had lots of great events already, and we've got several coming up. They are both a mix of in-person and virtual. So the most recent in-person event we've had was in Newport, looking at the Stevenson Street flood risk management scheme. And we've actually got an event coming up tomorrow about the daylighting of the dock feeder canal in Cardiff, although I have just been told that that one is full. So if you wanted to catch that one, you might have to join it afterwards and catch up with someone who was there. The last thing to say is just that the Welsh Branch is always open to new members and to anyone who wants to get more involved with the committee or with the branch more generally.
Catherine, I'm going to get told off if I don't mention the Rivers and Coastal Group's event, which is next week. It is our annual study day. It's an in-person event, and it will focus on coastal flood defence schemes, and it's based in Rhyl. So have a look at our website. It is next week. Thanks, Catherine.
Great, thank you, everyone. Looking forward to the next section, and I definitely encourage you to get involved with our branches or our groups like the RCG. Everything that we do is possible through our volunteers and our partnerships with organizations, some of which are here today. And now I'm going to turn it over to Piet from Arcadis, who's going to introduce our topic.
Yeah, thanks, Jane, and thanks everybody for joining us. So a very special topic today. We're going to talk about the Kakhovka Dam destruction in the Ukraine, and from our engineering perspective and from actuality, how we have experienced it. And you may remember we were all, I guess most of us were at the Flood and Coast conference in the UK, the CIWEM conference, when the dam was destroyed. And while we were at the conference, we heard about the consequences of the flooding that came out of that. And a couple of very young, very talented, but also some experienced colleagues from Arcadis spontaneously decided, together with some model developers from Tigron, which is a model that, digital twin model that we work with a lot, decided to build a model overnight, literally overnight, try to catch what has happened there, simply to find out, do we understand what exactly happened? Do we understand the consequences of that dam breach? Can we predict what will happen in the next days and weeks to follow here? And are we able, is it possible with current technology to develop such a model in a very short time frame? Because it wouldn't make sense here to build a model in a classic style, which would have taken us maybe a couple of months or up to a year. Our conclusions would come much later than any of the actual events would happen. So it was a bit of a spontaneous action, a challenge, an experiment that placed us in a very new kind of reality that we are all in. And that reality is a kind of a mix of the fastness that we have now with supercomputer calculations, artificial intelligence, use of big data from open sources, combined with the impact of social media that immediately bring out the results from these kind of calculations to every corner of the world, and combined, of course, with a kind of a reality of the new political situation that we live in. You already said we're not going to discuss politics, pros and cons here, but as engineers, we will have to think about what that means for our role in our societies and how we deal with our profession here. So I'm not going to tell about the details because Bas Agerbeek will do that in a minute. But basically, in a very short time frame, the model was built overnight. Almost within 24 hours, results were presented via social media. Immediately, there were reactions from Ukraine, from engineers from Ukraine, but also from other persons that took the message and said, hey, maybe we can help, maybe we have additional data. Hey, we think the model here, this is water level is too high and here it's too deep. So we got feedback on the model results, and those feedback gave us immediately a bit of a new type of experience that at least I have never felt before. I realized that as an engineer, you have a big responsibility in whatever you design and calculate. And usually the distance between yourself and reality is much bigger than it was here. Reality was very, very close. And we also realized that on one hand, we might be able to help, for instance, to guide emergency response and tell them where potential risks could be for flooding, but also where potential opportunities could be for saving people or driving into areas, etc. But on the other hand, we also felt the risk here that we may impact health and safety of people in this area. You might guide people into an area that is not safe, although you cannot recognize that from a distance. Or you may tempt or bring people into the temptation of doing spontaneous actions and maybe get involved in war actions, or maybe face unexploded devices that might float around. So all of a sudden, you're in the middle of a reality that usually when you sit quietly behind your desk and you do your mathematics, is not something that immediately, let's say, gets to you. So the situation came very close, the war situation. And it meant, on one hand, that we realized that we have fantastic new opportunities here. We were asked, for instance, by consulates from different countries and embassies to help. We were also asked by the International Red Cross for information that could help them in their emergency response. So we felt that this created new opportunities. At the same time, you have to be careful. It goes at very high speed, and what you do can have a large impact. So how do you deal with that exactly? You can think in terms of legal actions that you have to undertake. Maybe, and we thought, for instance, we discussed the use of disclaimers in our social media messages that we brought out. But it's not just about disclaiming your own responsibility here. It's also about warning people how to handle the information that they get from you. So we also thought in terms of how do you exactly guide people with the information that you provide to avoid that there are any health or safety risks. And then finally, another ethical issue that you'd have to deal with is, of course, the fact that you are in a conflict situation here. We definitely did not choose a side. We did not talk about politics at all. But you are in a conflict situation, and with choosing the side of those embassies that have their head in Kiev, you're on the Ukrainian side, whether you like it or not. And although you want to help everybody that can be helped, it is very hard not to choose a side. And you can even have impact on war actions without realizing it yourself. For instance, the model was extended after a couple of days to see the impact of the flooding in the weeks to come. That means that you also give an insight in how the flood would move out and how flooded areas might dry up later. That is basically strategic information that could be valuable for one of the parties that is involved in the war actions. So this all got through our head while we were working with this. We also realized that a dam, dealing with dams or with potential dam breaches will never be the same after this one dam. As you all know, we've had already next fatal dam breaches in Libya recently, more due to weather events, although also there the poor maintenance might be war impacted. Dams become an important topic when we say we are going to regenerate maybe the hydropower component of dams for sustainability purposes in the near future. I heard people talking about the hydropower as the forgotten workhorse of the green energy deal. If we think in terms of water shortages that will come with climate change and droughts, this may impact also the importance of dams. So dams are important. We'll have to learn how to deal with them, not only in these war-stricken areas, but also in our own areas. We have now maybe a possibility to do kind of dry exercise before there is any risk. You could already get an impact assessment of what a potential dam failure could look like. So these are all the kind of things that went to our head when we were doing this investigation. We were with Jane and with other colleagues at the Flood and Coast Conference, and spontaneously decided, how did we call it, Jane, to have a breaking news session on the early morning. Only a small group of people were available because nobody had planned it in his schedule. And that was the reason why we thought this is so valuable to discuss this, that we should do this a second time with a bigger audience and share the thoughts and also learn from you guys how you think about this topic. And so I'm happy to see over 200 participants here. And that's where I want to leave it for now. And I think we move over to the more exciting part of the presentation here with our colleague Bas Agerman, former colleague from Arcadis, who will present how we built the model and how it works. Over to you, Bas.
Yeah, thank you. Thank you, Piet, for also a very exciting introduction to what we've done. My name is Bas Agerbeek. I'm an advisor in water and climate adaptation, and I prepared a presentation to explain in more detail and also to show you some of the results that we produced directly after the Kakhovka Dam breach. So I'll share my screen. Yeah, should work. So let me. Oh. Not too experienced with Zoom. So something.
Don't worry, if we see your slides, you're just not in present view yet.
Yeah, the Zoom screen is blocking my ability to. Wait a second.
Yeah.
Take your time, no worries.
Okay, perfect. Now you see my full screen, I think, right?
Yep, looks good.
Yeah, thank you. So, well, I called this presentation "Visualizing Flood Impact on the Day of a Hazard." I think that's a suitable title after what you've heard Piet explain. So what I'm going to explain is, so in more detail what we did on the day of I think it was June 6th when the Kakhovka Dam was destroyed, and how we got the confidence to actually do this, and how we got the idea, why we thought it would produce reliable results. I'll explain more about Tigron, what Piet already introduced as well, and how it works, what type of technology it is based on, and how it's possible to present such results in just one day. As Piet explained, normally our flood modeling, if we create such a model, it can take weeks or months to create it. But in this case, we were able to produce reliable results in just one day. So then I'll show you what the results look like. We also made a web viewer, in which I'll also share a link in the chat. So you can also open the web viewer yourself and you can scroll through it, zoom in. It looks a bit like Google Maps, and then you can see what type of results we produced. And then you can think for yourself and how it can be useful in such a situation. Then I'll explain a bit about the validation of the model. Well, Piet already explained a bit about how we use social media to share the results and how we got feedback, or via crowdsourcing, we gained a lot more knowledge about the problem and the situation. And based on this feedback, we were able to improve the model. Now, how directly after the event, the model results were being used. and then a question how and in what way we should use this technology, if we should use it more often. Well, Pete just explained the political questions we should ask ourselves, and anyways, that's for the discussion later. So what exactly did we do, and how did we get the idea? Well, I think about a year and a half ago, I worked for the water board. We have one of our big rivers in the Netherlands is called the IJssel. It goes through the city where I live, or near the city I live, Zwolle. And the water board was interested in knowing if this model Tigron, which can create a model in just a few hours, would be able to simulate a dam breach or a river levee breach in a few hours. So if this model would be able to produce reliable results. And why is this relevant? Because if a dam breach happens, in advance you can never predict exactly how big the breach will be, what the exact location is. But with this model Tigron, when you start building it, you know exactly where you expect the dam breach to occur, and you also know exactly what the water level is in the river. So you can, in that way, with this knowledge, you can create a much more accurate result. And we created this model. We didn't have the measurements of a real dam breach, because our levees and dikes in the Netherlands, they're rather safe, and we have, and luckily at the flooding you see here in this image, it did not occur. But we did compare it with a more with a model that was built approximately a year before, which took a year to build. And we compared our result with Tigron, which created this breach flooding in just, well, we were able to create the model in 30 minutes. And the results were almost identical. So this was a very positive result. And because we had this recent experience, myself working together with Tigron, which is a Dutch technology company, Maxime Knepfle, Florian Witzenberg, Tijmen van der Zande, Niels van der Baan, those are Arcadis colleagues. After the news broke, we contacted each other and we discussed, would this be something we would be able to do in Tigron? And then we decided, we discussed a lot of the topics that Pete also mentioned about the ethical concerns we had. Could it be used for military tactical purposes, but we decided that the most pressing need for this information was for the humanitarian sector, that we already knew that the dam had breached, the impact was already there, but the detailed information about what street was flooded, how you can access certain areas to save people, that's something that's we thought was of a high value to these evacuation missions or relief work. So after discussing it with Arcadis internally, we decided to go on with it. So how is it possible in one day? Multiple technologies that have emerged in the last decade or so they converged in a way that made this possible. So very shortly about Tigron, that's a Dutch technology company. I believe it's about 15 years old, and it was mainly used by municipalities and to show the impact of climate change. So Tigron uses big data. It's able to, via APIs, collect from open sources various big data about streets, about the elevation of areas, about waterways and roads and water levels, and it all compiles it together using these supercomputers, the same computers that are also being used to train these big artificial intelligence models such as ChatGPT. And so it compiles and builds the model, and then you're able to do all types of analysis in a very integral, multidisciplinary way. In Tigron, you can show the impacts of heat stress, drought, extreme precipitation, and so also what happens if a dam breaches or if a levee breaches. The other technology we used, as Pete explained, was also social media. So on the day of the dam breach, when we had our results, we were able to show them in a web viewer, which I'll also show you in a bit. And we shared our results and our the assumptions we made, and the settings of the model on LinkedIn. And this, well, it contained also a visual of what happened, and we got a lot of responses. And as I said, these responses helped us or brought us in contact with relevant people that were able to help us improve or make the model results more reliable. So here you can see a result. Are you able to, Jane, can you confirm that you're able to see these moving images as well?
Yeah, we can see.
Yeah.
Okay, that's great. Then I'll quickly go to my browser. And if you like, I can also share the link I have in the chat. So you can also, am I able to share something in the chat as well?
Yes. Just make sure you put the chat to everyone, and then the whole group will see it.
Okay, host and panelists. Yeah. So I'm sharing the link right now. And so what you should see is a like a Google Maps kind of viewer. And now you see the satellite imagery, and you can zoom in all the way to where the, let me turn off some of the results. This is where the dam breach occurred. You can see the, yeah, so we had to, in the model, we had to put in what the width of the breach is, or actually it started at a smaller width, and then as the breach occurred, in the model, it grew more and more. Well, you can zoom in all the way to street level. You can even see buildings. It takes some time to load, but there are, in this model here in the left corner, you see that it predicts 20 days into the future. And we're now looking at, let me show you arrival time first. So if I zoom out, and well, an important location is Gerson, which is a bigger town or bigger city downstream from the dam. And you can see that this pink color, that's means that it took 4 hours for the water to reach this tributary over here. And then if I click further, this is the 20-day model, so it has rather large time steps of 6 hours. So 6 hours in the future, you see that after 12 hours, so half a day, the water reached Gerson, and you could see where flooding, even in urban areas, occurred along the river. And you can go all the way to, and you can see that it reached the ocean in about a day. This is one of the results. I can also show you the water level.
You see the red crosses. These are the reality checks. These are field observations.
Yeah, so via LinkedIn, we received these geo points from an environmental engineer, a very experienced environmental engineer from that lived in Gerson. So he actually went to these locations, and he made pictures of where the flooding occurred, and then we could compare the border of the flooding to these locations, and we concluded that it was rather accurately modeling the extent of the model of the flood event. Yeah, so you show water depth, speed is also very relevant to know, as if there's water flowing over a certain road, but it's a very low velocity. Then if the water level is, or the depth is 20, 30, 40 centimeters, you'll still be able to travel through over this road. But if it's if the velocity is extremely fast, such as where you can see these lighter colors, means 3 meters per second, or it's rather fast, then the road isn't accessible. That's also something we were able to show. We were able, out of the model, we're able to filter out all the roads, and then you can see when the road is green, you're able to travel on it. And we gave a setting that if the water level is more than 40 centimeters and with a speed of more than 2 meters per second, then the road is blocked. So here you can see, this is mainly along the river. That's, it would be difficult to reach this building at a certain time after the flood event. But then after a few days, as the water, it took a while. I think this area stayed flooded for a while, or maybe on the last day. You could see that some roads were accessible again. And as you can imagine, this is something that can be used by for relief operations. So let me go back to my presentation. I hope this gives you maybe some of the questions can be after this presentation. I can explain more about the viewer and how it works. I hope this gave a good overview. So we explained that we got a lot of feedback via LinkedIn or via social media. And initially, so Pete said we were able to build this model in one night, and that's correct. But we made one big mistake. We based the width of the breach on the imagery we saw in the news and from satellite images. And what we didn't consider was that the breach would grow to such an extent. So initially, we said one of the boundary conditions was that it would grow until 200 meters. Because that's what we saw in the picture and in the satellite imagery. But then after a day or so, the breach grew, and it got a width of 550 meters, which is allowed for a lot more water flowing through the dam. And this was also, and when we changed this, so Mikola Schlapak, that was the environmental engineer that gave us these that showed us which locations were incorrect. And he shared these geolocations. And when we made this adjustment, then the result was much more accurate. And after 2 days, there was also a Finnish company that, based on satellite imagery, showed what the water depth was. And that's also something I can show you in the browser. Yeah, so here you can see the results of Tigron compared to water depth in based on, so red is what is the water depth in the satellite imagery. So you can also see that it has information on this tributary. And if we compare it with what Tigron was able to produce, it's near identical. And you can zoom in rather far. So, and we also, when we learned about this, we also shared, so there were multiple updates on LinkedIn in which we shared all the information we had. So also what's ICE SAT, so the Finnish company produced, and well, it reached a lot of people. And so let me tell you about how it was being used. We shared it with so on LinkedIn, and we got contacted by, as Pete already mentioned, by the embassy of Ukraine. In the Netherlands, there's a Ukraine water platform. NGOs, the UNICEF WASH cluster. We also shared our viewer and how to use these results. The Presidium Network, that's an NGO that combines all these different types of information, such as where Russian troops are and specific relevant buildings such as power plants, and then they used our flooding information, so the water depth and the flow speeds, and they used this to coordinate relief operations. And yeah, other things you can do with the model is what we didn't do is, for instance, if there's a contaminant or if there's explosives that were transported due to the flood water, the model can make an estimation of where the contaminant moves towards and what the concentrations are. It can show where, after the water has flown away again, stagnant pools of water occur. And this might be relevant because the stagnant water in combination with sewage can pose a health risk. And if I remember correctly, there was even a cholera outbreak in this area. So as I explained, you can show the roads which are not accessible anymore, and you show the impact on co-infrastructure and ecosystems. And so, well, to open the discussion, or there's a presentation, but these are just some questions that I posed that we might discuss. I think this technology, it can be extremely valuable in if there's an extreme rainfall event or a dam breach. So I set up, I think we should provide this easily accessible information about the direct and indirect impacts of water hazards. Well, almost in this case, it was during the event, but at least directly after the hazard. We have the technology now. So the supercomputing, the big data, the crowdsourcing, and it's, in my opinion, it was, I think it's essential information for, because if you make a model in advance, you estimate what the location is of a breach, or how extreme a rainfall event is, but you never know exactly what it is. But if it has occurred, and then you can very quickly model it, then you know exactly what the impacts are. And this is, well, in this case, it was used to coordinate evacuation and relief efforts. And then after you made the model, you can use it also to determine what longer term impacts are, and to design measures to mitigate these impacts. And well, what's necessary is an expert team that stand by, that whenever such a hazard in the world occurs, can just start with the modeling and then share it. So that's my my presentation.
Okay, thanks, Bas.
Yeah, thank you all for listening.
We'll take a deep breath. We'll have a discussion later. I'm pretty sure there will be plenty of questions. An amazing presentation. To give us all a bit of a different perspective, I think it's good that we have a completely different presenter now, Roger Falconer, who will also help us a bit to switch to a UK perspective here. Ukraine is far away, although a lot of the things we saw, of course, are valuable for all of the UK as well. Roger Falconer is an emeritus professor at Cardiff University, but also chair professor at several universities in China. A very experienced man in dam modeling, dam breach modeling, extreme flood events. So he will give us a bit of in a bird's view. 10 minutes only, unfortunately, a bit of an overview of how he sees the evolution of the technology on the UK side, and hopefully also help us a little bit to translate what we saw from Bas's presentation, what it means for the UK, and how we can relate, let's say, more classic types of looking at dam breach and flood models versus this revolution that Bas just presented to us. And then we'll discuss later the comparison between those two. Over to you, Roger.
Thank you. Am I able to control these slides, Sarah? It's Jane, sorry. My name is Roger Faulkner. I'm from Cardiff University, Emeritus Professor at Cardiff University. I first started working on modelling dam breaches in the mid-90s when we were concerned about various dam failures, both in the UK and worldwide. And more recently, I've been involved in studies where it was clear to me that the codes that were being used for traditional modelling techniques, Bas gave us a very exciting presentation of the future. I'm perhaps talking a little bit more about historical modelling techniques. In the early days, these modelling tools were only available through HR Wallingford in the UK, Deltaris in the Netherlands, and DHI in Denmark. But in the mid-90s and the early part of this century, these models have become much wider, much more widely used, and by consultants worldwide. However, we're still stuck with the traditional, what we call the, I can't move it on. Can I? Jane, can you move to the next slide, please?
Yeah, sorry, I had set it to remote control, but it says you're doing it. You want to try one more time, and then if not, I'll do your next slide.
Okay.
Try one more. I see your mouse moving around, so you're on the right track. You just got to get to the little buttons where the arrows are a little bit to the left of where you are. Yeah, unfortunately, Zoom is a little bit fiddly with making these buttons visible. So a little bit there, you're so close. One more to the left. Perfect, that's the one.
Okay, so what I have seen over the last few years is quite a lot of misuse of models for dam break problems, and probably a gross underprediction of the true water level that would occur should the dam break. So I'd like to introduce this problem to you, if I may. And I had a lot of discussions in the media, both in the UK and internationally, about the Kakhovka Dam failure, and really just to explain the implications and the differences between a dam failure flood wave and a more traditional flood wave due to heavy rainfall. Yeah. So the classic, what we call dam break problem, is as sketched here. You have your dam, you have a water level on the left-hand side, a high water level on the left-hand side, upstream of the dam, and a low water level downstream of the dam. If the dam breaches instantly, then you've got a vertical water face. So it's a very challenging problem to solve numerically. There are steep water surface slopes generated, and these generate what we call grid scale oscillations through the advective accelerations using a traditional ADI scheme. So here we see on the left-hand side a dam break problem simulated using a traditional artificial alternating direction implicit scheme. Now, this is the sort of scheme that's widely used for most practical 2D model studies worldwide. It's fine for low slope, relatively small slope flows, and for rivers and coastal waters and so forth. However, the problem is when you try to apply this scheme to a dam breach type failure, you have this almost vertical water surface, and that gives you these grid scale oscillations, violent oscillations. The only way you can get the model really to work for these is to increase your roughness considerably, and therefore you smooth out these violent oscillations. Now, the problem with doing that is that you don't know how much of your friction is artificially dissipating the energy of the flow, in other words, the real process, and how much is smoothing out these numerical oscillations. So we need to capture this shock to model the dam break failure properly. And here we can use a wide range of shock capturing algorithms. Here I'm going to show you a TVD scheme, total variation diminishing scheme. And here you can see we can predict the dam failure quite accurately. And here we can see the dam moving downstream. Now, Delft Hydraulics Laboratory many years ago did a dam break failure experiment here, and you can see that failure. This is a physical model. But this is a dam break, simulation of the physical model. And when we compare these predictions to the actual dam failure, we can see the dotted line is the measured value and the continuous line is the computed value. And you can see 6 meters downstream, 9 meters downstream, 13 and 17. In all cases, by and large, the TVD scheme has predicted the breach quite precisely. Mm-hmm. Now, In the UK, we have seen the use of the traditional ADI model for some inappropriate circumstances. I won't go into details, but I'm certainly aware of several. One major simulation in Wales where caravans were predicted not to move on a particular site due to a big storm. And in fact, when we applied the TVD scheme, we found we had much higher water levels and the caravans were predicted to move as they did. But the one project which was fascinating to me was the Boscastle extreme flood event that occurred in 2004. So it isn't just dam failures where we have to look at using shock capturing events. This is a short river basin. You may remember it very well. It occurred in 2004 and it was in, I'm not sure if it was July or August offhand, but it was not expected. It was the first time that people in the UK took climate change very seriously, in my view. We had this massive storm in July or August, almost a tropical event. 200 millimeters fell in 5 hours, and it was assessed to be a 1 in a 400-year storm. There was extensive damage to properties, bridges, highways, and other infrastructure, and it was one of the best recorded extreme flood events in the UK with trans and supercritical flows throughout the valley. So this is the valley. It's a small town, Boscastle, but it's got very steep slopes around it, and it experienced this massive storm in July or August in 2004. And there were about 100 vehicles upstream in a car park here, most of which were picked up in this storm and transported out into the sea. Just offshore here, offshore of Boscastle Harbour, we have one of the most heavy metal contaminated areas in the region. But one car in particular blocked this bridge and exacerbated the storm on the water level, almost instantly. So I think I'm going backwards now for some reason. I'm not intending to.
Yeah, it's the little buttons are fidgety.
Okay, sorry, I've got the hang of it now, slowly. So here we can see the damage that was done, and this was just a small brook, and you can see it divided around the town. You can see the blockage in the bridge here and so forth. So we wanted to model this using a traditional model. Here we happen to use the McCormack scheme without shock capturing, and we used the scheme with shock capturing. And we used also the simple inertia kinematic wave, which has been used quite widely for rapid model flood predictions in the UK, or was being used at that time. And we wanted to predict the main flood parameters, the elevations and inundation extent compared to rack marks. So here there were 30 rack marks which were picked up after the storm. The flow was from right to left, and this is a vertical projection of the town. So here you can see the wave moving through the river at the time. The bridge caused the blockage, and you can see the water accumulates coming back upstream from the blockage as well. And what we found with the TVD scheme, it gave very accurate predictions of the water levels based on the rack marks that we had on all the buildings and that had been picked up after the storm event. And when we did comparisons, we found some very interesting simulations. The TVD scheme picked water levels up here. I don't know if you can see my cursor. We picked up water levels here in this band here, 3 meters, and I just showed you that these match the rack marks very accurately. When we go to the removal of the TVD scheme or the shock capturing algorithm, and we revert back to the simulations of a traditional 2D model, you can see that the water levels are at least 1 meter lower, predicted to be at least 1 meter lower. And this was a relatively small event compared to a dam break failure. And when we actually ran the kinematic wave model here, we found we got over predictions again. So we found from this study that the inclusion of shock capturing was extremely important for extreme flood events, which we've seen more frequently in the UK in recent years, and in particular the dam break problem. We applied this to many studies and many dam break failures that are reported in the literature, but in particular we applied it to the Malpassa Dam breach failure that occurred in 1959. The Malpassa Dam is located on the southern coast of France in the Reyran River. It's 12 kilometers from the town of Fréjus. It was a concrete arch dam, 200 meters crest length and 66 meters high. The breach occurred due to very heavy rainfall over several days, and flash floods swept along the Reyran Valley to the town of Fréjus. The breach wave at the dam site, was 40 meters at the time of the failure, The wave was propagated downstream at 70 kilometers an hour. It was 3 meters high at Frejus and it destroyed 2 villages on the way. There were 423 fatalities, 135 children, 246 adults, and 27, and I'm not sure whether they were adults or children. So here was the traditional unstructured finite volume grid model, and the dam site was on the French Riviera. And here were predictions. This is one example of predictions. I've not produced animations here, but we have animations. Flood levels and inundation after 1 hour. And you can see after 1 hour, the dam site is here and it's got down to here. And then it progresses gradually further down. So we compared this with other studies carried out by other academics worldwide that were using shock capturing algorithms. You can see our model agreed very closely with theirs. And at the various sites, we were predicting values which are pretty close to the track levels. When we studied this using an ADI scheme, we got figures which were generally much lower because of this artificial dissipation or diffusion that you were including through having to increase significantly the bottom roughness. And then we went on to predict zones of a major hazard risk for adults and children. Not surprisingly, when the flood wave came through the river basin, pretty well all the area was of severe danger to both adults and children, but more so adults, less so for adults and children, less so for adults further downstream. So in conclusion, dam break failure is difficult to model accurately using traditional models, and the levels are under-predicted with widely used 2D models. Shock capturing additions to the code are desirable to predict steep wavefronts and trans-supercritical flows. Models with shock capturing features give accurate predictions of the peak levels for extreme flood events, and this is very important for the emergency services. And these models of dam break failure can provide valuable planning tools for emergency services. They can't provide them in real time, as we saw earlier from BASIS simulations, but they can be predicted in advance of a dam possibly failing at some stage in the future, and producing emergency maps for the emergency services so that they would know where to prioritize their efforts in the event that any dam might fail. So thank you for your interest.
Okay, thanks very much, Roger. That was interesting, and I think also good to see that completely different type of approach. Also very valuable, I think, to learn from the comparison. But we'll get to that in the discussion. I think, Jane, maybe you introduce the panel to us, how we get ourselves organized.
Sure, absolutely. So we're going to have, what might be 15 minutes. We'll kind of see how it goes. A little bit of an open discussion between the panel members themselves about all of the kind of opportunities and, constraints and issues that we've discussed today. And then after that, we will go ahead and take some questions from the audience. And I should also mention at this point, we are joined by Neil Gunn. That's the only person that we haven't introduced yet. He joins us from Willis Towers Watson, also very long time CIWEM member and supporter of what we do. And he's going to be joining our panel and providing a little bit more perspective from the insurance perspective. I know we got one question from the panel in the chat. David, do you want to kick us off either with that one or a different one?
Is that the one from Neil?
From Neil, yeah.
That was about unexploded ordnance, and if you could predict its destination moved by the floodwaters downstream. Is that the right one?
Thumbs up, yeah.
Who would like to answer that? Is that Bas?
I think it was for Bas. Yeah, it came in during that part.
I misheard the first part. What would we be able to predict?
If you knew where mines and unexploded ordnance were,
and we actually discussed it,
failure, would you be able to predict where they'd be transported and deposited, and therefore understand the increased hazard in certain areas?
And we discussed this internally at Arcadis, and we had a whole expert team with expertise on these bombs, and they did a whole inventarization on the types of bombs, which ones float, which ones are wouldn't float, and And we concluded that it was actually very difficult to be able to do this, and we had to make a lot of assumptions, and we decided not to. It is possible to predict so floating objects or objects that will travel over the bottom of the flooded area, but we didn't. Yeah, we were not certain that it would be accurate enough to do this. And it would be very difficult to validate, and we weren't able. We didn't know exactly what the locations were of these, and the type, which types there were. Yeah, maybe.
But it may be a science or technology that will evolve over time, with more and more data available. The science of how to deal with unexploded devices is already at pretty high level. So that could be combined with this hydrodynamics knowledge, but you have to make one very important warning here. We should realize not only that you operate in a war zone here, but on top of that, a lot of the information is very hard to judge whether or not it is correct. That's one of the most difficult things in a situation like here. Verification of the data is complex and uncertain. And it's not only that information might be inaccurate or missing or whatever, it could also be intentionally be false. So that makes it even more complicated how to deal with those data. But it's definitely a point for future consideration, I would say.
Can I add a comment?
Yeah, Roger.
If we look through the literature, there's extensive data on how sediment particles move in flows, and we've known that for years. When I got involved in the Boscastle study, I realized that the real problems got much, much worse when the car was floating down from the car park and ended up in the bridge. And as soon as it ended up in that little bridge, it caused an instant blockage and the water level rose rapidly, which was a major problem for the emergency services. I then started to look with my team at Cardiff University back in about 2004 as to how a car moves in a flood. And I realized there was very little in the literature. And somebody had said to me a few months later, why don't you look at children in particular in floods and people? So we started a series of experiments with China, which is still going on, still ongoing, on how cars move in. We've published many papers on, we developed formula from laboratory experiments. We in fact wanted and had the approval of Dor Cymru to put a car in a spillway in the Elan Valley dams and look at what were the conditions under which it was first picked up and moved. But we were told we couldn't do that because it would be an oil in a cheap car and so on and so forth. But to what Neil is I think it was Neil asking the question, it can be done, but it can't be done with the existing studies. We would need to treat bombs like sediment particles, if you like. We would need to undertake extensive experiments to work out all the criteria, all the coefficients and so forth under which they move, and then that could be put into models. And once it's put into models, then it could be predicting them quite accurately. So maybe this is a good opportunity to find some funds for the future to extend the work that's been done at Cardiff from just looking at cars and people to bombs as well, if you want to. Thankfully, I've retired as an employee now, so I don't have to get involved in bombs.
Well, interesting comparison. I would like to extend the comparison maybe to both of you, to Bas and Roger. Let's say react to each other on the two presentations, because they're quite different. Roger's presentation much more, I would say, scientifically founded in hydrodynamics, while Bas's presentation is more from a perspective of big data and statistical analysis, but with remarkable precision in the results. I was wondering, Bas, when you made a comparison with satellite data, I almost thought he's making a mistake. He's showing us the same data set twice. So good. So it's amazing. But how do you feel when you look at this new technology, Roger? And Bas, what do you think when you see, let's say, the more in-depth science? Do you think we miss something when we model in Typhon? Maybe start with you, Roger. What was your thought?
Well, I think you need both tools. I think they're equally valuable. I think, let me take as an example, because this has been directed by the Welsh CIWEM. Let me consider something like the Elan Valley dams, for example. In the middle of Wales, for people that are not familiar, we have some of the oldest dams in the UK, and they're remarkable structures. And these dams are typically 30, 40 meters high. And downstream of these dams, in the town of Elan, for example, or Rhyadr, just downstream, maybe, I don't know, 3 or 4 kilometers, maybe even further than that downstream, you have small communities, several hundred people living. So what we would want to know, in my view, what the emergency services would want would be a map in advance of the extremely unlikely possibility that the dam might fail. Where would the dam, what would be the height of a dam break failure wave at a town like Rhyadr downstream, and where would we need to move children to, for example, and adults, if there was a breach, small breach starting in the dam and we felt the dam was going to fail. And we saw that about a year or so, no, several years ago in Sheffield. So I think running a dam break problem using a traditional hydrodynamic model, which can predict the water levels quite accurately, would be useful to provide emergency services with data in advance. So in the event, an extremely unlikely event of a dam break failure, they would know where to prioritize their efforts. So from that point of view, I think they're useful. They are no use for real-time simulations, which is what Bas presented and was most impressive.
So over to you, Bas. Do you think, let's say boldly, your model would make Roger's models redundant in the future?
No, I think as they're more scientifically proven, and these additions of this numerical inaccuracy because of the shock, what Roger just explained. This is also something I'd like to discuss with Tigron, if it would be possible to add this to the breach modeling suite. This shock wave and this numerical to make it more correct. But yeah, I think that the best situation is if you build a dam, that you also build a hydrodynamic model that you can then use in a real time in the event that it occurs. But a lot of dams don't have this. So then this technology of Tigron can be used to give a first estimation. And then later on, perhaps in designing measures, then you should also build a more scientifically sound model. But I also had a question, Roger. If this numerical inaccuracy, isn't it, is also because the grid size, if you make the time step smaller, then you reduce the numerical inaccuracy, and also if you reduce the grid size. And that's something because we use these supercomputers, and normally I also build models which I run on my laptop, but running a model like Tigron is like compared to running a model on 1,000 laptops. And because of that, the grid size was actually very small. It was less than a meter, I think. And in these these legacy models, such as also made by Deltavis, I think they have grid cells of 10 by 10 meters or even larger. So
absolutely, I agree. I don't recall what the grid size was in Boscastle. I think it was 1 meter. It was a very fine resolution.
Yeah. And even with the 1 meter grid cell size, you got this numerical inaccuracy.
Yes, we did there. There are quite a number of unique characteristics. I agree with you, the finer the grid, but that's another problem, that lots of studies have been done using these models, not by experienced consulting companies in many cases, and the results are not always that reliable.
Yeah.
Bas, I see also some questions in the chat on that.
Just going to go there.
A little better what the model exactly is to type. Is it a model? It feels almost like it builds itself. You just give some boundary conditions and some instructions from the outside, and then the model more or less automatically generates the data that it requires from the internet. Is all open source. It's all open source data, and it seems to, and that's how I imagine AI as well myself. It seems to invent itself and build itself more or less as a black box, where the most important way to check whether it is reliable or not is the comparison with actual data, and then it shows that it is remarkably correct. But how is the model exactly built? I mean, you don't work with cross sections and all other kind of hydrodynamic detailing that we used to use for hydrodynamic or for hydrological or rainfall runoff modeling. So can you give us a bit of an idea of the secrets behind it?
Yeah, well, you do have to add, change a lot of settings and add boundary conditions. Also, so that the downstream boundary is the sea. So you have tidal fluctuation. We had to add that, though that information was known. We also knew the size of the reservoir upstream of the dam and what the water level was at the moment that the breach occurred. We did an estimation about the depth, and that was also of the breach when it occurred, and also the initial width. But we were able to calibrate the amount of water flowing through the dam because we knew these geolocations that gave us the extent or the reach of the flood event. So that was actual data we could use to calibrate and improve the model. So I think there might be some inaccuracies in how the model calculates the amount of water going through the breach, but by changing these coefficients or these boundary conditions, we were able to have the model create what we were able to to see in the field.
Okay, let's move over to David. I see a hand from David.
Just thanks. That's a really interesting discussion. Just going to go to a question from Brian Reed on the Q&A, which I think is really insightful. Brian is a humanitarian WASH trainer, apparently, which has implications for his question. What information would you want from professionals on the ground to help you develop these models? You've mentioned water levels, but is there anything else? Because obviously Brian might have access to people that are on the ground in this situation.
Yeah, Bas, maybe you already mentioned contamination. We also mentioned flow velocities as a critical.
Those are things that the model presents as data that the humanitarian sector can use. So the flood velocities, water depth, if spread of contaminants is something that the humanitarian sector wants more knowledge about, or if they want to simulate it with the model, then they could provide at which locations they expect industry to have certain contaminants, and then we can model the spread. If this is then can provide relevant information for relief workers. But this is something I think we should discuss maybe in a smaller committee with and it was also what was discussed with the WASH cluster in the UN and with the NGOs. But I think mainly they have the other data, and if they combine it with the information of the flood event, then they can make strategic decisions.
Yeah, maybe I can put it also this way. What we did now was really a kind of an experiment as an observation. We observed what happened and tried to understand the event, but also tried to find out if we were able to get our hands around it, to describe what happens and to predict it. But it was not a risk assessment. I don't think we had already complete overview of potential risks in such an event and how to deal with those risks and how to try to mitigate them or how to try to react to them in an emergency response. But I would say the basics is this model now, and you can build potentially those risk assessments and those risk impacts and also follow-ups on that. But we're at the beginning stages of finding that out, I would say. I see a hand from Roger.
Yes, can I just make a brief point to add to Pete and Baz's points? I think the velocities and the depths combined are very important factors, just like I've forgotten the name of the chart now for sediment transport that everybody uses. And we have published, not only myself, but many other people as well, have published over the last 15 years or so, and widely cited because a lot of people seem to be doing it now. Look at what depth and what velocity will cause a child, for example, or an adult to lose their balance in the flow and then try to manage. And we know that children can, adults even Mark Spitz can't cope with currents more than about 2 meters per second, so they couldn't swim to safety. And this is very valuable information for the emergency services, because they don't want to send their staff into areas where the velocities are so high and the water is so deep that they couldn't survive. So I know that the Environment Agency and so forth produce some reservoir maps. I'm not convinced they're that accurate, but that's another point. But but you need more than just the water levels. The water levels are critical, obviously, but the velocities and depths combined, and the stability of individuals or cars and vehicles, for example, is also important.
Yeah,
thank
maybe
you.
Good for the discussion that we. I'll come to you back later, but maybe we also involve Neil in the discussion to get a bit of an insurance perspective here. We talk about loss of life here, but about risk, but also about tremendous damages. So I would love to hear from him how he perceived the let's say the news in general about dam breaches we had in recent time and the impact, but also the way how we are dealing with it here now. Would it in any way impact your business, Neil, and would you look different at how to insure risks or how to deal with those risks? What's your take on that?
I think if you're looking in terms of the Ukraine in particular, then there is a restriction on the amount of insurance cover that's available because of the fact that there's a war there. So you can get fire and flood, but war tends to over-trump that. Most land-based activities can get cover, but particularly around agriculture, because there's been a systemic prosecution of attacks by the Russian on agriculture, that is difficult to get. What risk management companies have been doing with Ukraine is looking at where there's been more intense and less intense activity, and then mapping where cover might be available on a case-by-case basis.
Let's put it in the UK. Let's forget about the war issues, but let's put it in the UK context. Is dam failure risk, is it insured at all? If you live downstairs of a dam and it would fail, and it would destroy your house, would you be insured?
Yes, it is. There is cover, but there are limitations to that cover as well. I think in a mature economy, like much of Western Europe or North America, you're really looking at the asset managers of reservoirs, and you're looking to them to be managing the risks overall, and that's where your societal capacity sits. So it's with the engineers and the reservoir managers as much as it's with the insurers.
And looking at, let's say, the recent events and also this presentations, do insurance companies have the impression now that they're facing bigger risks, also financial risks, than they did before as a result of climate change?
I think there's been some recent work done by, for example, the Bureau of Meteorology and reviewed by Gabriele Villarini, lately of the University of Idaho, and Hayley Fowler at Newcastle, where we're looking at peak flows and how the carrying capacity of the atmosphere is going to amplify things like probable maximum precipitation and PMF. There isn't yet a full response for the insurance industry per se, but what we're seeing is the asset managers of those things, perhaps from mining with tailing storage facilities, as well as operators of large reservoirs and hydro and water supply, are taking a different view of risk as they look forward. And I noticed that Claire Waller's actually here. Claire Waller has worked with a number of people to redraw guidance on the estimation of PMP in a UK scenario. So those things are in hand, and then that's affecting things like spillway design and review.
Yeah.
Claire's asked a great question on the chat as well. Has anyone else, don't want to highlight your competitors, Bas, given the work you put into this, but has anyone else done a similar exercise at this site in Ukraine? And how did that compare with different results? Was it a confusing picture to the end users?
Now, Bas mentioned the Finnish effort. I don't know if there were others as well, maybe doing model efforts, Bas?
Yes, I know that I think from I don't know which organization exactly, but there was an environmental impact assessment. I think also by the that's RVO. What's that in England? The Enterprise Agency in the Netherlands. Yeah. They did a study where they think Deltaris was also involved, but I haven't seen these results yet.
Yeah, maybe good to hand it over to
David
and help us with maybe some more questions from the audience to take it a bit broader than our panel here only. And what I would like to hear maybe from the panel, or maybe you see any questions from the audience in that direction, is the ethical issues that we mentioned. Is it something that people worry about? Did you see any questions from people that really say, oh my God, what are we doing there? We should stay away from that? Or, well, yes, this is the new reality. This is the way how our profession is developing. Any thoughts, any questions in that directions?
Well, I'd just like to make a comment. I think we're focusing here on dams, and we all think of a dam as being a structure which is significantly higher than the surrounding terrain and valleys and so forth downstream, villages and so forth downstream. But also the technology we're talking about here is equally applicable to embankment failure. And if I just think of the city of Cardiff, for example, the centre of Cardiff, the river flows through the town. It's pretty flat. There are several 100,000 people living below the top of the embankment through much of Cardiff. And if that embankment failed during a flood event or overtopped, then you would have a dam break failure problem, and much of Cardiff would be flooded, and it could have serious consequences. And you would need all the emergency services to be focused in the right areas in that sort of scenario, which is different from a dam in terms of height. But the impact can be much more significant because Cardiff is the capital city of Wales with a population of about 350,000, a relatively small population globally, but it's still high population compared to the rest of Wales, for example.
And maybe for you both, Bas and Roger, maybe others to fill in as well. What did you think when the dams in Libya failed? And we had already a lot of news. I think that was simply a rainfall event and a flood event. There was no violence involved there. There might have been neglected maintenance or operations or investments on the dam. Probably 10,000 people or more killed there. We still don't know. And we know it was a gigantic disaster. That seems like a disaster that could have been avoided, but wasn't. Any thoughts?
There's not been much in the media about the dam's failures in Libya. My impression from reading what has been written is that they were not particularly well designed, but I don't have any evidence of that. And I don't think that's been proven. But
I think it's a question of, with Dana, more of the maintenance of the dams. The design's been by a reputable engineering company from the former Yugoslavia.
Sorry, that's what I meant. That's what I meant.
Yeah, and much of their stuff's still standing up, including another dam elsewhere in Libya that's still there. But what I would say is it's worth mentioning it because it's also another case where engineering infrastructure that needs to have people monitor and maintain it has been left neglected because there's this intersection of conflict, climate change, and a failing state. There isn't a way of resolving that problem. There's no UN ordinance that says you can march in and sort it out, and no will to do it either. Yeah,
and perhaps if I'm not aware if they had a proper early warning system, that if they would notice, if they've seen that there were some cracks or things starting to break because of the event, that they would have been able to warn people more earlier in advance.
I've seen some engineering reports that were published in the run-up to in the years before, and there is an early warning system within Libya, but it doesn't really stand up very well. The flood, the storm system, as it was named, Daniel, by the Hellenic Meteorological Agency, on the 5th of September, made landfall in western East Libya on the 9th, and so they would have had quite a long lead time, in particular a whole day before the storm crossed Libya and caused the failures around Derna. So I think this is a societal problem there. And I've also seen, recently I went to something called the Global Flood Partnership, which is an intersection of emergency managers and academics in flood mapping and modelling, and there was quite a lot of discussion of it. And the ECMWF were publishing forecasts of this event some time before it made landfall, and not necessarily of a dam failure.
Yeah, I want to like to take the discussion one level up for the last couple of minutes, and let's say forget about the dams and about Ukraine, but let's look at the impact of the other elements that were introduced by Bas for our profession, and that's this combination of artificial intelligence, supercomputers, and social media that have turned to have such an impact now on the fastness with how we get results, how fast we can present them, and also the speed how intense reactions come in, brings reality within a split second at our desk now. But what does that mean in terms of opportunities, but also in terms of challenges for our profession? What does it change, or doesn't it change anything? Is it business as usual with this new steps that we make? Who has an idea? Who has a thought on that? Maybe Roger, Bas, maybe Jane even.
Yeah, I think we're able to present this valuable information about what Roger mentioned, these water depths and flow velocities, that this information that's now currently lacking in the coordination of relief work. And I spoke to a lot of people that work in that sector, and they said a lot of people they go into areas without knowing anything about the situation, and they'll just see what they encounter there, and it might be a dangerous situation. So yeah, these real-time models that can be built very fast based on big data using supercomputing. We did not use artificial intelligence, but perhaps it can have a role in the future, maybe in predicting water levels, or you can add that to the models, perhaps. But I think it's a very valuable tool, and if it's better than having no information.
Let me make it a bit more challenging. Let's say also for Roger, almost at let's say looking back on a career, the sense of, did this really change anything? Are we becoming more responsible in our work, and do we need other skills? Or were we always responsible in this way for the impact of our designs? And is it just become more visible now?
No, I think this latest technology is extremely valuable. I think that if you just take the embankment scenario, which I took as a hypothetical case, and I referred to the embankments in Cardiff, in the UK, like much of Europe and so forth, we have the I've got a reservoir panel and so forth, inspecting dams and embankments and checking regularly and so on. So it's unlikely that you would have an extreme failure suddenly. Mm-hmm. But if you were to have a failure due to extreme rainfall event, let's take the embankments in Cardiff, which many people in this participating today will presumably come from Wales and will be familiar with it, will know that you would not get, in that scenario, an instant failure. You would notice cracks developing and small leakage, and you would have probably a day or so before you started having serious problems, in which case you could set this model up and so forth. Yeah. It's not like the title of this talk was the Kakhovka Dam, where we were looking at almost an instant failure. That would be quite rare. Yeah. Even in the Libya situation, the dam didn't fail instantly, as I understand it.
Exactly. I'll try again. I want to get a little bit more of it still. Back to the younger generation, Bas, looking at our responsibilities and our impacts that go beyond designing. And I think it requires new skills from us. You were so active using social media here, and you encountered here, Bas, that both Russian and Ukrainians would react via social media. And we would also have the question for ourselves, for instance, not only do we impact health and safety of people in the region, but also how about the health and safety of those on the Netherlands side that work on the model? For instance, don't we have to be careful here with information about private data from these persons when it comes to name and address, for instance? We live in a different world now. So what were the thoughts of the team when you were working on it? But we didn't have everything ready when we started, but it evolved in those days.
No, I did not get in contact with any Russians. They didn't contact me. So, but it was mostly from the relief and the humanitarian sector and the embassies that contacted me. What we did notice was that our server was the amount of it's always, yeah, so bots are always trying to hack it, and this amount increased by 5 or 10-fold, and they could also see that it was from Russia. So that's you might have to increase the security when providing this information if it's related to a war situation. And also our viewer shows or presents the data in the viewer, but you're not able to extract the data. And we only, when we were contacted by humanitarian or people, we validated that they were real persons, and we had calls with them before we actually shared the data so they could use it. So that was one of the things we took into account.
Okay, I see now, Jane, you have a
opinion. Unfortunately, we're getting close to time here, so I just wanted to leave with a couple of thoughts and a final question from the audience. I think I appreciate first of all of your time and coming together and generating this discussion today. I think you've given the audience a lot to think about, a lot of exciting visions for what's possible. But I think most importantly, the take home for me is how important it is that we work in partnership across industries, across organizations, across countries, and share this type of information and help each other understand what is the best practice and kind of keep moving this forward. So I'll leave us with a final question from the audience, which is from Tom Toogood, which is, he says, a challenge is ensuring that those responding to an incident have one validated version of the truth. The technology and opportunities are exciting. However, we need to be careful that the information is coordinated and does not confuse the responders. So I guess it's not actually a question, but a good sort of final takeaway, I think, at least for me from the event. And I don't know if any of you want to have a last second final comments on that point before we wrap up for today.
I think it was the point that I tried to make. We have to be even more careful with verification of data and information that we share here. And given the speed at which they come at us, the challenge is even bigger to make sure that we are careful there. I think responsibilities in our job not just became more visible now. Of course, we always should make designs that are solid and safe, but our responsibilities definitely also grew. And we will have to learn over time which new skills maybe also will come with these kind of responsibilities. This interaction with social media, for instance, is very exciting, but we also all know that there is a lot of crap coming via the social media as well. So there's a lot to think about, I would say. We don't have the conclusions to everything, but it is pretty obvious we enter a new era with new opportunities and new challenges. It's an open door, but that's where I want to leave it here.
Thank you. And yeah, if this group is interested in continuing the discussion, I'm happy to help organize another webinar in the future. Otherwise, do check out the recording and share it with your colleagues who maybe didn't get to join us today. That'll be up within a couple of days or so on CIWEM's YouTube channel. Thank you again to Piet, Baz, Neil, Roger, David, Catherine, and all the teams at the RCG and the Welsh Branch for helping us put this together today. I really appreciate it.
Okay.
Yeah, thank you for hosting.
Thanks very much.
Bye.
Bye-bye. Bye-bye, everybody. Bye-bye.